Welcome back, guys. Today I'm gonna start working on a new sensor, that is TMP101NA, that's a temperature sensor. Regarding the recent videos we have showed, we have been working on different digital temperature sensors. So let's add a new one to that series. And to know more about this sensor, let's have a look over the website, that is controleverything.com, and here search on for this sensor, that is TMP101NA. Now we see that it's a digital temperature sensor with alert function, and it's a I2C temperature sensor, 9 to 12 bit user selectable resolution, and as you can see the accuracy is there. So some of its features you note it down. Now you can purchase this sensor from here also. For today's video tutorial, I am gonna interface the temperature sensor TMP101NA with a particle photon, and I require a particle code. So go to the resource tab, and here you can download the particle code sample as a zip file right from here. Also, you can have the opportunity to download the code from GitHub repository. That's the repository is Control Everything Community. Now, first, this here is our sensor, that is temperature sensor TMP101NA, and this here is a particle photon. Now, to make a connection among the particle photon and the sensor, we need an I2C shield, and this I2C shield is available on the website controleverything.com. Now, the reason why we are using this I2C shield is to make connections with other I2C devices a rather easy job. So gently press over the particle photon over this I2C shield and make a connection. Now we want to make a connection among the sensor and the I2C shield, and we need a connecting cable just like this. Now gently make a connection among the sensor, and while making this connection, make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and similarly we have to follow this rule for the I2C shield also. Finally, at the very end, we need to power up our particle photon, and a micro USB comes into the picture. Now gently insert it over the power jack and you can light it up. Now we are done with the connections part. What we require is the particle code so that we can show the interfacing and the working regarding this sensor. So we require a particle code so that we can have the interfacing of our sensor with the particle photon, and for that the first step is to log into the website, that is github.com, and here we have to search for the repository we are looking forward, that's Control Everything Community. Now click over it and here search for the sensor, that is TMP101NA, as you can see on my screen, and here we are, temperature sensor, and this is the particle code we would like to explore. But before that, let's have a look over the instructions we need to follow to pursue this code. It says that we have to log into a particle photon and set up the device, and the steps are being provided on this very link. Let's have a link view so that we can familiarize this with all the relevant guidelines we have to follow. As you can see, we can connect, and using operating system install in node.js, Windows, everything is there. You just need to clear your mind and get over it. Now next we have to download the code or git pull, and we can go to the online ID and copy the code there. Now build.particle.io is that online ID. Here we have to copy and paste our code, save it, and after that you can see we have to go to the next step, which is to verify and flash the code on the particle photon, and the code output will be shown in the logs which are in the dashboard link. And this is the dashboard link I'm talking about, and here you can have all the relevant output regarding the sensor, as you can see. So what do we need now is to have a look over the code, particle code, so that we can clarify every and each doubt. So it's a .in extension file, as you can see. Let's talk about the code. Now in the code, first of all, we have included application.h along with spark wiring I2C.h header files, and we have defined the address of the sensor, that is 0x49. Now in the void setup function, and we have some set variables, as you can see, and we have initialized I2C communication as master and initialized serial communication with the baud rate equal to 9600. Next we have the sending command, that's the writing section part, where we have selected the configuration register having address 0x01, and we have set continuous conversion comparator mode 12-bit resolution, and the command for that is 0x60. Now we are done with sending the commands to the sensor. Now what we want is to have the response back from the sensor, and that's exactly we're gonna do. We are selecting the temperature data register, that is 0x00. We are requesting and reading 2 bytes of data. We are pulling 2 bytes of data for temperature data, as you can see, and here the conversion of the data takes place which is all according to the resolution and the dependencies and the formulas applied in the datasheet. Now what we're going to do is to put our code onto the run, and we have to display the results on the dashboard, which says the temperature in Celsius and Fahrenheit. So this is how our code gonna explode, do, run. Now what we're gonna do is to show the working. So let's have it. Now the time comes to have a look over the working of this code. So for that, copy this entire particle code and here open up the link for the build. That's the online ID for particle photon. Here what we're gonna do is to create a new file, that is TMP101NA, as you can see on my screen, and here paste the entire code. Now save the code and we have to verify and compile the code. Now it's done. Now we have to flash the code. While flashing the code, we have to check for the magenta flash, which will confirm that the code is good to go, and we can have our output in the logs in the dashboard link. Now just now we have our magenta flash on the particle photon, and the notification of flash successful is there on the here, right here. Now what we're gonna do is to open up the dashboard link so that we can have the output in the logs. As you can see, user log, and here we have our output data and the temperature, which is in Celsius and Fahrenheit scale. Now it's, as you can see, there is a very minute change, as there's now what we're gonna do is to exhale and let's see what changes. As you can see, the temperature changes in the both scales. Now again, as you can see, the temperature changes again. Now this is how the particle code works along with this sensor. And now what we're gonna do is to have a look over the specifics, the features and the applications regarding this temperature sensor TMP101NA. The TMP101NA device is a digital temperature sensor ideal for negative temperature coefficient and positive temperature coefficient thermistor replacement. The device offers a typical accuracy of ±1 degree Celsius without requiring calibration or external component signal conditioning. The TMP101 device features SMBus Two-Wire and I2C interface compatibility. The device allows up to 8 devices on one bus. The TMP101 device offers an SMBus alert function with up to 3 devices per bus. Now, this device is ideal for a lot of applications like power supply temperature monitoring, computer peripheral thermal protection, cell phones, battery management, thermostat controls, environmental monitoring and HVAC, and a lot more. This sensor is available and can be purchased from the website controleverything.com, and you can get the code from resource tab. After that, you can download it from there also. Also, you can get the code from GitHub repository, that is Control Everything Community. In the end, I would just like to make it clear that at any point, if you are not able to understand any part regarding any section of this video, you can have your further queries on controleverything.com, and you can post your comments on the community page. For blogs, articles which are relevant to this video, you can have a look over instructables.com and search us for there. Also, to subscribe more video tutorials which are just like this, you can go to our YouTube channel. Now, in the end, I hope you enjoyed this video and have a good one of yourself. Thanks a lot for watching.